Hey everyone, welcome to today's lesson. If you remember yesterday, we started our new chapter on polynomials and factoring. We talked about what a polynomial was and how to name them based upon both the degree and on number of terms. Today's lesson is going to be a super short lesson because, well, one, the concept isn't too difficult, and also we had clear sight testing today, so we are just going to have the notes today, and then tomorrow we'll play a game with the last couple of days' lessons. All right, so our objectives for today is going to be able to add and subtract polynomials. Okay, so that is our main focus for today. All right, now I'm going to throw in some vocabulary here as well from yesterday. So I have a term that has, well, I have a polynomial that has 3 terms. Okay, so this is a trinomial. And I am adding over here another trinomial, has 3 terms. Okay, so we have not added. If you remember last chapter, we multiplied and we divided and we raised things to a power, but we have never added technically. So we always have a number out in front of our parentheses that we are supposed to distribute. However, on these, we just have the number 1 out front. So if I distribute everything 1 to everything, I don't ever change anything. So in essence, I just drop my parentheses there. So you can actually physically write this step, or you can kind of do this step in your head. And same with the second one. I have a 1 out front that I am distributing to all the terms. And again, that just means I drop the parentheses. That doesn't change anything when I multiply it by 1. Now, once I have multiplied everything by 1, I just have to combine my like terms. But be careful with this. When I have 5x squared, and when I was multiplying it, let's say to 3x to the 7th, when I multiply coefficients and I add exponents. When I am adding, for example, I have 5x plus 2x, I am going to add the coefficients, but I keep the exponent and the variable the same. Okay, everybody wants to add exponents, but I only add exponents on problems like this one when it's a multiplication problem. Okay, so don't do that step. That's a very common mistake here. Okay, so when I write these, I always put them in standard form. And if you remember from yesterday, that means highest exponent to lowest exponent. So let's start with our highest exponents. I have 6x squared plus 1x squared. That gives me 7x squared. So again, you don't add the exponents. You add coefficients and keep. Okay, I'm going to go to our next terms, negative x and a negative 2x. That gives me negative 3x's. And last, I have my constants, positive 3 and a negative 7. That gives me a negative 4. So my final answer here would be 7x squared minus 3x minus 4. All right, let's do the same thing on number 2, except I'm not going to rewrite everything since I can just kind of in my head imagine that those parentheses go away. All right, and I want to again put them in standard form. So start with the highest exponent, which was to the 3rd power, so negative x to the 3rd. I'm going to combine that with my squared terms. So I have a negative 9x squared and a positive 8x squared. That gives me negative 1x squared or negative x squared. All right, I'm going to keep going. Now I'm going to do my x terms. So I have a positive x and a negative 2x. That gives me a negative 1x or a negative x. And the last, I have my constants, which is a positive 2 and a positive 4, which gives me a positive 6 when I combine them. Now, just as a kind of a review from yesterday, if I named this polynomial, I have 1, 2, 3, 4 terms. So this is a polynomial with 4 terms. Poly meaning many. If I named it based upon the degree, the highest degree here is 3, that would be a cubic. Again, you don't have to actually do this in your homework. I am just trying to remind you of what we did yesterday. If I went up to the first example, that one had 3 terms, so that was a trinomial. And if I named it based upon its degree, its highest degree was 2. That was the hard one. That was a quadratic. All right, let's try one last one. Why don't you pause the screen here and see if you can do this one on your own. All right, let's see what you got. Again, I'm not going to rewrite it. I'm just in my head going to imagine those parentheses disappearing. Start off with your highest exponent, so squareds. 6x squared plus 4x squared, that gives me 10x squared. If I combine my x terms, we have a negative x and a negative 5x. That gives me negative 6x. And last, I have a plus 3 with nothing to combine it, so I'm just going to keep a plus 3. If I name this, it has 1, 2, 3 terms. That is a trinomial, and it has a degree, highest degree of 2, which also, again, was that hard one, a quadratic. Again, that's just a little review from yesterday. All right. Now we're going to move on to subtracting. Here is where people make mistakes left and right. And I think it's because people get lazy with the distributing process and they don't want to actually rewrite everything. Okay, so we are going to distribute and get rid of the parentheses again. Now on the first one, there's technically a 1 out front. Oh, sorry. There is technically a 1 out front. So when I distribute that 1, again, nothing changes. Okay, so I'm going to rewrite this like I did the last one. Okay. Now here's where the mistake is made. On the second set of parentheses, I have a negative 1. That is different from all the other ones. Okay, so this time I have to distribute a negative 1, not just to the first one, but to all of the other terms. They are all going to switch signs. So it would become a negative, sorry, it keeps switching on me, negative 4x squared. And it would become a positive 3x and a negative 1. So all of the signs in the second set of parentheses need to switch. And then I can do what I did on the last slide and combine the like terms. So I would put my x to the third powers together. So a negative 6 and a negative 2 would be negative 8x to the third. And then I would put my x squareds together, which I only have 1, so minus 4x squared. Then I would put my x terms, so plus 5x and a plus 3x would give me 8x. And last I would put my constants together, a minus 3 and a minus 1 would give me a negative 4 there. And as a quick review, I have 4 terms, making that a polynomial. And I have to the third degree as the highest degree, which would make this a cubic. If you think the degree of 3, you think cubed. All right, let's try this number 5 here. I'm going to show you maybe a different way which you show less work. So on the first one, you can erase the parentheses in your mind. Now on the second one, I'm going to turn this into a plus, but since I'm distributing the negative, I'm going to make this a negative 3x, and I'm going to make this a positive 2x squared. So if you don't want to rewrite it like you did in the first one, you at least have to put the correct symbols on the second set of parentheses. All right, so now let's combine our like terms. I'm going to put my x squareds together. I have 4x squared and a positive 2x squared, which will give me 6x squared. And then I have a negative 3x all by itself. And I have a negative 1 all by itself. This has 3 terms. This would make it a trinomial. And its highest degree is 2, which is a quadratic. All right, if you want to pause here and try this one on your own, go ahead and try it. All right, here's what you should have gotten. I'm going to take this subtraction, I'm going to make it a plus, but that would turn that into also a positive, and 3x into a positive, and the 4 into a negative. All right, let's combine your like terms. Start with the biggest exponent. Negative x squared and a positive 8x squared. They cancel. That's 0x squared. It's gone. All right, we're going to move to our x terms. I have a 3x, and that is it. Okay, if I put my constants together, I have a 12, a 6, which is 18, and a negative 4, which was 14, positive 14. And if I name this, I only have two terms, making it a binomial. And its highest exponent is this 1 right there, which, if I graphed it, would be linear. All right, so that was our slide on subtraction. My last slide is a mixture of the two. Go ahead and pause the screen and see if you can do these last two, and then we'll go through the answers and be done with the notes for today. All right, let's see what you got. Ignore the parentheses on the first. Since it was a plus, we can just ignore it since I'm distributing a positive 1 to both of them. If I combine my like terms, I had 4x squared and a 2x squared. That gives me 6x squared. Combine my x terms, 6x, negative 9x. That gives us negative 3x. And last, positive 7 and a positive 1 gives us a plus 8. Final answer there is 6x squared minus 3x plus 8. Now, number 8 is the most missed one because people forget to distribute that negative. So I'm going to turn that into a plus, and everything else behind it switches signs. Okay, now I can combine my like terms. Start with the highest exponent, so 2x to the third and a negative x to the third. That gives me 1x to the third, or just x to the third. Combine our squareds next. I have 5x squared and 8x squared. That gives me 13x squared. I only have negative 3x there, nothing to combine it with. And last, I have a constant of negative 11. So that is our final answer there. All right, if you guys have any questions, again, don't hesitate to contact me. Hope to see you guys soon. Bye.